Welcome back to my channel. In today's video, we'll be going over some basic dplyr functions to be used in data pre-processing and a little bit into data cleaning. This will actually be the first video in a series aimed at teaching basic data cleaning. So of course, before you get to cleaning data, you do sort of have to sort of pre-process it. Sometimes, actually often you do. And as usual, we'll be using a data set that's always available in the R environment, the Palmer penguins. So if you do want to follow along with today's video, all you'll have to do is copy and paste the code that will be linked in the description below. So the first thing we're going to want to do, obviously, is load all of our relevant libraries. So we'll want dplyr, because that's what we're using to clean. You'll want to load the Palmer penguins, obviously, because that's the data set we're going to be using. And then you'll want to call the data function to actually get the penguins data out from the loaded package. All right, so now that we have this loaded up, the first function we're going to be looking at is the filter function. And much like what you would be doing in, say, Excel, where you might have, a filter saying, hey, I only want to see, dates from 2020, the filter function in R works very similar, in a very similar manner. So for example, for this data set, let's say we just want the Adelie species of penguins from the penguins data set. We can call the filter function. We can then call our data set. We can then call the variable upon which we want to apply the filter, in this case, the species. And we're looking for an exact match here because we know exactly the name of the species entered in the data set, which is Adelie. And so if we run this, we see that our new data set called analyses only has the Adelie species, so our filter worked properly. Great. The next one we'll be looking at is the select function, and what this allows you to do is basically say, hey, I have this data set. It might have, the penguins data set doesn't, but let's pretend we have a data set with 100 columns. And obviously you probably will not be needing all those 100 columns. You might need 3, 4, 5 for your whatever analysis you end up doing. And this is what allows you to only select the columns you're interested in and put them in a new data set that you can then work with in a much neater fashion. And for this one, you call your function, which is select. You call the data set, which in this case is penguins, and then you'll call whichever columns you're interested in this case, species, body mass, and flipper length. So if we run this, what happens is, boom, we have a new data set called selected columns, and we only have species, body mass, and flipper length. Tremendous. All right, the next one we're going to be looking at today is the arrange function. Now, this one, I'm going to admit, is the one I use probably the least in pre-processing, because it often ends up not being extremely useful unless you're dealing with very organized and structured data that will have some sort of periodicity to it. So for example, if every 10th entry or every 20 entries, there's going to be some sort of change, then it's very useful. But if you don't have that, then it ends up not being all too useful. But anyways, so the arrange function allows you to basically arrange much like you would do in Excel, descending order, ascending order, whatever you want. So again, to use it, you call your function, which is arrange. You then say on which data set you would want, or data frame, I guess in this situation, which data frame you want to arrange. In this case, we'll be using the selected columns, which we created before. And then we'll say we want to organize it by body mass. And body mass is a good thing to arrange because it usually is a continuous variable, which will either grow or decrease. Now, one thing to note here is that you can do this, from smallest to highest or from highest to lowest. If you do not specify any sort of what's the word I'm looking for? Any sort of constraint, it will do it from lowest to highest naturally. So if we go ahead and run this and we look at our sorted data, what we see is that we start with the smallest body mass all the way up to, well, what is the tallest, the highest body mass here? Not available. That's a big body mass. No. So 6,000. All right. All right, the next function we'll be looking at is actually one that is extremely useful, especially if you're dealing with data that has to do with, sometimes currency exchange or changing any kind of units, metric units to imperial or those kind of things. And it's the mutate function. And what the mutate function allows you to do is basically make a calculation or make any sort of modification to an existing column and then create a new column or a new date, or actually no, a new column with, with that calculation you made. So to do this, you call the mutate function. You then call the data set that you want to use. So in this case, we'll be using the data set that we sorted previously. And then we'll say we want to create a new column, which is going to be called body mass in kilograms. And it will be equal to the body mass, which is in grams divided by 1,000, because that's how grams and kilograms work. And so if we run this, we see that in our mutated data, there we go, our body mass in kilograms is exactly corresponding to our body mass in grams divided by 1,000. And this is useful if you want to present data in a specific manner. Most of the time, whoever your shareholders end up being, they'll probably have a preference. Or if your graph maybe is very crowded, you wouldn't want, very big numbers showing up. You might just want, a little 2.7, which is much neater and cleaner. All right, and the final dplyr function we'll be looking at today is called summarize, and usually summarized specifically combined with the group by function. So this one's kind of a combo package. And what this will allow you to do is basically say, hey, I know I have, let's say specifically for the penguins data set, I know I have 3 different species, and I want to know what the average or the maximum or the minimum or whatever sort of arithmetic manipulation on a specific variable. So for example, in this case, I want to know what the mean body mass of each species is. So the first thing I'll want to do is I'll want to create a grouped data set using the group by function. So I'll say, hey, I'll use the group by function on the penguins data set, and I want you to group it by species. And what this will do is it will create a new data set that is going to be just, it's going to arrange everything, but it's going to make sure that everything is arranged neatly by species. So only the analyses, then only the gentoo, and then only the chin straps, right? And then we're going to use this data set. And what we're going to do is we're going to say we want to summarize it. We want to summarize this data set, and we're going to create a new value called mean body mass in grams. And then we will say this will be equal to the mean of the body mass in grams. So the mean here is not in the name; it is used as a function. So if we run this, what we see is that we get a table, and then we get the mean for each of the different species. Not exactly, actually. So I'm noticing that there are NA values for the analyses and the gentoo. So that probably means that there is missing data in the body mass for the analyses and the gentoo. But one trick you can do whenever you do run into this, you can type in na.rm equal true, and what will happen is you'll basically be ignoring all of the missing values, and your operation will run anyways. So if we go ahead and we run this again with this na.rm equal true, it should work, and we should get a value for the analyses and the chin straps. And yeah, so we got, the gentoo. So yeah, as you can see, we have 3 different means for each of the different species. And this can give you a nice little indication of how species might be differing and how you might want to look into your data into the future, and how what kind of insights you might be gleaning from your data. All right, that is all for today's video. I hope you enjoyed it. This will be the first in a many-part series. As I said before, this will cover some very basic dplyr functions that you might use in sorting and doing maybe some basic data, EDA, some basic data cleaning. In the next video, we'll be doing basically intermediate dplyr, which will be much more geared towards doing actual data cleaning. And after that, we'll be working on other ways to clean up your data. And this will be a maybe 6 or 7 or maybe 8-part series where by the end of it, you should be able to clean even the messiest data you might encounter, I should say. And then after that, we'll be going into some basic statistics, and then we'll be going into some basic how to do EDA from the very, very, very beginning all the way down to doing actual modeling, not just stopping at doing data cleaning and data visualizations as most videos on EDA do. So I hope you enjoyed it, and I hope you look forward to the videos coming in the next couple of days, maybe weeks. All right. I still don't have an outro, so yeah. Have a good day.